So hello friends, in this video we are going to understand no load operation of a transformer. Basically, once you look at the construction of a transformer comprises, specifically single phase transformer comprises of a transformer core, primary and secondary winding. So here this rectangular portion is nothing but a transformer core. This is the primary winding and this is the secondary winding. Primary winding is the one where we are going to connect a supply voltage, and secondary winding is the one where we are going to connect a load. Now there are varieties of possibility, like our transformer may be at no load, at half load like 50% loading, or at a full load. Now in while you connect with a different loading or even no load, so at that time we have to understand, because even while on the secondary side there is no load, even transformer will continue to draw some current, and while transformer uh, is drawing a current without any load, this is something known as a no load operation of a transformer. Now here if I connect supply voltage Vs over here, so then the transformer will draw a current I0, and this current is known as a no load current. Now this no load current will be having two components. One is a working components IW, and other is a magnetization components. Now we can categorize this particular current into two parts, like working current is the one which is drawn by a transformer to supply a losses. Losses in the transformer, is like some eddy current losses are there and hysteresis losses are there. So in order to supply those eddy current and hysteresis losses, transformer draws a no load current IW, and a transformer draws a current in order to magnetize this core, and this is something known as a IMU. It is also known as a magnetization current. So now let's get in detail that what exactly IW and IMU are, and how exactly we can correlate in terms of power. So this IMU, as we discussed, it is magnetization current. So it is associated with reactive power Q, and IW is something known as a losses. So as we know, like reactive power are consumed by the, you can say, inductor. So we can show this magnetization current with an inductor, and we can show the working current with a resistor. As you know, if we compare IMU with current which is drawing in the inductor, so working current we have shown with a resistor, and we know the phasor diagram of resistor. V and I both will be in phase, so its phasor diagram will look like this. Here it will be a working current. Now if we look at those losses from the percentage of full load current, so even at no load it will draw a 4 to 6% of the rated current of the transformer, and the loss components of the current, which is also known as a working current, will be 1 to 2% of the full load components. So from this figure we can easily identify, like working components of the current is quite lower there as compared to magnetization current. So almost magnetization current is 3 to 4 times higher than the working current. Now if we combine these two things, like magnetization current with inductor and a phasor diagram of this, in which we can easily rectify, like magnetization current will be lagging 90° from the supply voltage, and working current where supply voltage and working current will be in phase. Now if we try to draw here the combined phasor diagram, so as compared to the supply voltage, as we know that magnetization component of current will be lagging as compared to supply voltage by an angle of 90°. So here we will be having a magnetization current, and the working current will be in phase with a supply voltage, and we have seen like this IMU will be almost 2 to 3 times or 3 to 4 times as compared to working current. So as let's say this is 1, so 1, 2 and 3, so here this will be our working current. So if we combine these two things, so we can draw a combined phasor diagram like this. Now you can easily observe that here this theta is, or our angle between the voltage and the resultant current, which is also known as a no load current, is greater than 45 degree. So almost, so that's why at no load we will be having, okay, 0.2 to 0.3, because cos 70 degree will be almost 0.2 to 0.3.